So this one is exercise 2 of metals. Metal is an important topic, as I mentioned. Like there are certain topics which are important. You have to learn a lot of things in this topic. Memorizing basically. So the first 21 questions, as I mentioned, are already recorded. So I will start with 22. Okay. So this is question 22. The reactivity series lists metals in order of the reactivity. To find out which is more reactive metal, zinc or tin, the following experiment could be carried out. A piece of a zinc shiny surface is there. It is added to a tin nitrate, a salt of a tin. Piece of a zinc surface still shiny, no reaction, and the zinc covered with a gray deposited with a gray deposit. So our reaction is there. Okay. This experiment could be carried out with other metals. Basically, what happened, like piece of a zinc surface still shiny, no reaction is there, and if and the surface of a zinc covered with a gray deposit, the surface reacted only, inside does not. This experiment could be carried out with other metals, and the results recorded in the table, then the order of a reactivity could be deduced. So if there is a reaction happen, it means element is more reactive. Like if the zinc is able to displace, then it is more reactive. It's not able to displace, it is less reactive. So complete the table of the result. The reactivity is given to us. The order was found to be like we have manganese, we have zinc, we have tin, and we have silver. So uh, the first row is done for us, like tin nitrate. When we add manganese, there's a reaction because the manganese is more reactive, so it will displace tin from its compound. Silver is less reactive, so it cannot displace, and zinc is more reactive, so it can also displace. The second one we have to complete. You can use a screen annotation to complete this. If the reaction happen, you will write R, or you can also tick. And if reaction does not happen, you can put a cross. You can annotate on the screen. First one is manganese nitrate, manganese 2 nitrate, and we add a tin. So we have manganese and we have tin. Can tin displace manganese? Yes or no? So as you can see, tin cannot, because tin is less reactive than manganese, so it cannot displace manganese from a compound. So what it will be? It will be no reaction. So no reaction, you can put a cross here or you can write NR. You can also use screen annotation to fill up the columns. Then we have a manganese nitrate and we use silver, Ag. Will it react? We have a manganese nitrate and we are adding a less reactive metal silver. Will it react? So again, no reaction. So what we'll write? We'll write NR. And then we have a manganese 2 nitrate and we are adding zinc, Zn. Can zinc displace manganese? Again, no reaction. Okay. So both of all these cases, there are no reactions because the manganese is the most reactive in this the given reactivity series of the four metal. That's why there is no reaction. Then we have silver 1 nitrate. So silver 1 nitrate, which is Ag is +1 and nitrate is -1, so AgNO3. And in AgNO3 we add tin. Will it react? So we have tin and silver. Silver salt is there and tin metal, because tin is more reactive. We have tin we have silver salt, and we have tin metal. Because tin is more reactive, so more reactive will displace the less reactive. So the silver is the less reactive and tin is more reactive, so it will displace. And when it will displace, it will form tin nitrate, and it will form a silver metal. So the reaction happen, yes, the reaction will happen. Same thing, if silver 1 nitrate and manganese, Mn, will it react? Yes, it will also react. Why? Because it is more reactive, so more reactive displaces a less reactive. Then we have silver nitrate and zinc Zn. So if we have Zn, again the zinc is more reactive than silver, so it will react. Then for a zinc nitrate, we are adding these metals. So if we have a zinc nitrate and we are adding manganese, sorry, tin first. So zinc salt is there and we are adding tin. Will it displace? Zinc salt is there and we are adding tin. Will it react? No reaction. Why no reaction? Because tin is less reactive, so it cannot less reactive cannot displace more reactive from its compound. If we have a manganese, we add a manganese. So simply, if you are drawing an arrow, like example, what we are adding manganese to zinc. So if we are drawing an arrow downward, it means it will displace. But if we draw an arrow upward, it will not displace. So here, zinc nitrate, manganese, it will react. But if we add a silver to zinc salt, like we have a zinc salt and we are adding a silver, so as we are drawing an arrow upward, so there will be no reaction. Okay. So the idea is that the more reactive metal displaces the less reactive metal from its compound. Write an ionic equation for reaction between tin atom and a silver ion. Look, first to write an ionic equation, better to write a symbolic equation, like first complete equation and then convert into ionic equation. So silver 1 nitrate was reacted with tin. So this is a formula for silver 1 nitrate, because silver is +1, nitrate is -1. So AgNO3. And we added a tin, which is Sn. As a result, it will form tin valencies +2. So it will form tin 2 nitrate as the reaction will occur, and it will form a silver atom. Okay. Then balance the equation. So we have like we start with oxygen, 3 multiplied by 2 oxygen. So we put 2, oxygen is balanced. Silver is 2, so we put 2, silver is also balanced. And tin is already balanced. So this is a balance equation. Because tin is 1, nitrogen 2, oxygen 6, and silver is 2. Now we write the state symbols. All nitrates are soluble. So what is the state of nitrate salt? Aqueous. What is the state of the metal? Solid. All nitrates are soluble, so this will be aqueous. And what is the state of the metal? It will be solid. So this is actually the equation, but we need an ionic equation. To write an ionic equation, there are two ways to write an ionic equation. One is like first write solid, liquid, and gas. If one side they are existing as an atom or a molecule, other side it should be an ion. And the second method is you cancel out the common ion in aqueous solution and write remaining what is left. So first, I prefer to write first solid, liquid, or a gas. So what is solid, liquid, or a gas in this equation? We have a tin, solid. There is no liquid, and the other solid is silver, Ag. So two silvers are there. First, we write the solid. There is no liquid, there is no gas. Now, what we do, if one side it is existing as an atom or a molecule, the other side it must be an ion. Because in ionic equation, ions turn into atoms or molecules and atoms turn into ions or molecules. So one side we have silver atoms, like two silver atoms, the other side it should be silver ions. And for ions, don't write the number like this. This is considered as wrong. Like you cannot write the number as a subscript. It should always be a coefficient, like it should always be before. Same thing, if one side we have tin atom, the other side it should be a tin ion. So this is an ionic equation for reaction between silver ions and tin atoms. Is it clear? Anyone having a doubt or a question in this? Any question or doubt? Then there's also another way of writing an ionic equation. First, you write a full equation and cancel the common ions in aqueous solution. So in aqueous solution, we have nitrate is common, so we cancel out the nitrate ions. And then what we are left with, we write as it is. Like we are left with two silver, so we write two silver. We are left with one tin, one tin. We are left with tin, because in aqueous it must be an I, tin I, and then silver atom. So this is a second way of writing. First is like solid, liquid, or a gas, right? And then if one side it is an atom or a molecule, the other side it should be an ion. But to write an ionic equation, the best thing is you write a balanced symbolic equation. Because sometimes you may write equation, ionic equation correct, but you may not balance that. So it's better write a complete equation so you don't have to balance the ionic equation. You'll get the balance part as well. So if a substance is aqueous, it will always exist as an ion in ionic equation. The following redox reaction happen or occur. You can see manganese is there reacted with tin ion, turn into manganese ion and the tin atom. Indicate on the equation the change which is oxidation. Which change is oxidation? Oxidation is a loss of electron, and give a reason of your size. So when Mn changes to Mn plus 2, this change is oxidation. And why this changes, they mention indicate on the equation. So we have to indicate how to indicate on the equation. You will draw arrow from Mn to Mn plus 2 and you will say this changes oxidation. And why? What is the definition of oxidation? Oxidation is a loss of electron. So because there is a loss of electron, that's why this change is called oxidation. Explain why experiment of this type cannot be used to find the position of aluminium in the reactivity. If you remember, as we discussed about the aluminium, the nature of aluminium, if we have a piece of aluminium, the top layer of aluminium is not actually aluminium. What it is? It is aluminium oxide. And what is the disadvantage here? Like we cannot use to work out the reactivity of aluminium in this manner. So the reason is that the aluminium is having an oxide layer, which is like less reactive, you can say. So that's why we cannot work out the order of aluminium by this method. So there's an oxide layer on aluminium, which reduce the rate. As a result, you cannot exactly find, because when we work out the reactions of aluminium, the rate of the reaction with aluminium. So initially what happened, like if we have like volume of a gas is there with aluminium. So in the beginning, the reactions are slower and then suddenly it increases. So why this part was slower? Because of oxide layer, it was reacting. Once oxide layer is removed, then the reaction of aluminium will start. In part B, potassium and calcium are very reactive metals at the top of the series because their ions have different charge, K plus 1 and Ca plus 2. Their compounds behave differently when heated. Explain why ions have different charge. Why these ions have different charges? So what is the reason for that? Because they belongs to different groups of the periodic table, so they have different number of electron in the outer shell. So why the ions have different charge? Like example, why we say potassium is +1, but calcium is +2. We say aluminium is +3. So what is the reason for that? Because they have different number of electrons in the last shell or a valence shell. Like in case of a potassium, it has 1, and the calcium has 2 electrons. So they will lose different, like metal have a tendency to lose the last shell electrons. That's how the metals react. Because they have different number of electron in the outermost shell, that's why they have different charges on that. Their hydroxides are heated. If the compound decompose, complete a word equation. If the compound does not decompose, write no reaction. Potassium hydroxide, this we did in the last session about the thermal decomposition. So potassium and sodium hydroxide, what are they? They are stable to heat. So if they're stable to heat, what we'll write? We'll write no reaction. Does not decompose. Physically, it can change. Like if you have a potassium hydroxide solid, you can melt potassium hydroxide, but chemically it does not change. Chemically, it remains same. Calcium hydroxide, when from hydroxide from calcium to copper, when we decompose, what it will give? It will give a metal oxide plus steam, or you can also say water as a compound because the word equation is there. So you can say calcium oxide plus water. When we heat potassium nitrate, metal, as I mentioned, you have to memorize that table about the thermal decomposition of a nitrate. So potassium and sodium nitrate, when we heat them, it will give potassium nitrite plus oxygen, or sodium nitrate gives sodium nitrite plus oxygen. So potassium nitrite, the formula of potassium nitrite is KNO2 and oxygen is O2. Then we have to balance the equation. So if we put 2 here, the equation will be balanced. Same thing happen if we have a sodium nitrate. On supplying the heat energy, it will also give sodium nitrite plus oxygen. Nitrate is NO3, nitrite, ITE, nitrite is NO2. Then we decompose calcium. So here it was potassium nitrite plus oxygen. When calcium till copper, they have the same trend of a decomposition. When we heat, what it will, their nitrates, when we heat the nitrate, it will give a metal oxide plus nitrogen dioxide plus oxygen. So we'll observe a brown gas is given off. Why brown gas? That is the oxide of a nitrogen, which is brown in color. So it will give calcium oxide plus nitrogen dioxide plus oxygen. Then the equation must be balanced. So you have to, if you try to balance, so already 2 is written here. So it is obvious calcium should have 2 and nitrogen. This 2 multiplied by 2 makes 4. So we need 4 nitrogen. So it will be 4 here. And oxygen is already balanced. If you see 4 multiplied by 2 makes 8, and 8 plus 2 makes 10, and 10 plus 2 makes 12. So here also we have 12. So this equation is balanced. See the weightage, 17 mark question. So if you compare the exam, it's of 80 marks. If you have 17 marks, it means like 25% approximately, not exactly 25, but approximately 25% of quarter of your exam paper based on this topic. So it's a very important topic. Same like organic chemistry, you will find organic chemistry questions also 17, 16 marks. So they have a high weightage, these topics. In question 23, an important ore of a zinc is a zinc blend. How zinc blend is changed into zinc oxide. So what we do, we roast in air or heat in air or oxygen. Write a balance equation for a reduction of a zinc oxide by carbon. So if we have a zinc oxide and we have carbon, so as a result, it will form zinc and carbon dioxide. So equation must be balanced. So if we put 2 here, oxygen is balanced, and 2 here, zinc is also balanced. A major use of a zinc is galvanizing. Steel objects are coated with a thin layer of a zinc. This protection protects the steel from rusting. Even when the zinc layer of a zinc is broken or scratched, explained by mentioning the ions and electrons why the exposed zinc does not rust. And it's of 3 marks. As I mentioned the last session, structured answer should be there for this one. First thing, zinc is more reactive than iron. Iron actually, steel, you can use the term steel as well because steel is an alloy of iron and copper. So zinc is more reactive than iron. So as more reactive metal, zinc will lose electron and it will oxidize. So zinc will turn into, and it will react. Iron does not change, remain as atom. Why? And about the movement of electron, what will happen? The electron will travel from zinc surface to, like this is a zinc and this is a piece of iron. Zinc is more reactive than iron, so zinc will turn into zinc ion and its electron transfer to iron surface. So as a result, if mostly electrons are there, so as zinc is losing, so this oxygen and water does not interact because iron should be oxidized, like iron should lose electron. If there are more electrons on the iron surface, so iron is not able to lose electron because to form a rust, iron must turn into iron ion. Iron 3 oxide is there, so it must lose 3 electrons. But the problem that because already lot of electrons on the surface of the iron, so that is preventing iron from losing electron. So zinc is more reactive than iron or steel, you can say. Zinc will lose electron and oxidize and will turn into iron and react. And iron does not change, remain as an atom. Or you can also say electrons transfer from zinc surface to iron surface, which prevent iron from losing electron or oxidation. So always the structured answer, a 3 or a 4 mark question, same points you will mention. So this was question 23 from exercise 2 of the metals. I'll share another link and continue this topic.